Today we'll be taking a look at our final two ways to prove triangles are congruent, and those are angle, angle, side, and what's called hypotenuse, leg. So if you take a look at this first example, notice the two diagrams. We're given two pairs of angles in the first, two angles in the first triangle are congruent to their corresponding two angles in the second triangle, and we have one pair of congruent sides. However, this isn't considered angle, side, angle because the sides that are congruent are not between or included between the pairs of congruent angles. So instead, this is what we refer to as angle, angle, side, abbreviated AAS. Notice again, the S is outside of the angles that are congruent. Now, angle, angle, side is really just an extension of angle, side, angle. And the reason is, if we know the three angles in a triangle add up to 180 degrees, and two angles of one triangle are congruent to the two angles in the second triangle, then their third angles also have to be congruent. So really, any triangles that demonstrate angle, angle, side, the angle, angle, side relationship, would end up being congruent by angle, side, angle. So angle, angle, side provides us with another shortcut to show triangles are congruent. Let's take a look at a few examples. So in the following examples, we're asked to determine if the triangles are congruent by angle, side, angle, or angle, angle, side. So in the first one, we're told AB is perpendicular to BC, that's what this symbol here represents, meaning angle B would be a right angle, and we're also told DC is perpendicular to BC, meaning angle C would be a right angle. Now also looking at the diagram, they marked in that segments AE and DE are congruent to one another. And that's given in the picture, so really we should have been told it in the problem as well. So looking at the diagram now, we have one pair of angles that are congruent and one pair of sides. We're out of given information, but looking at the picture, hopefully you notice we have a pair of vertical angles. So this is an additional pair of angles that are congruent. Now, looking at where the congruent sides are located, notice that the congruent sides are not located in between the congruent angles, but they're one of these exterior sides. So this would be considered angle, angle, side. And yes, the triangles would be congruent. Take a look at example 2. Here we're told we have parallel lines. Both BC and AD are parallel, and AB and CD are parallel. So I'll put one arrow on each of those lines that are parallel and two arrows on each of these. So looking for transversals in our angle relationships, if BC and AD are parallel, then these two angles must be congruent because they're alternate interior angles. For the same reason, if AB and CD are congruent, this angle and this angle must be congruent because those are alternate interior angles of AB and CD, since they're parallel. That means we have two pairs of congruent angles in the two triangles we're looking to show are congruent. We're out of given information, but when I take a look at the diagram, I notice both of these triangles share side AC. Now, since AC is located in between the congruent pairs of angles, this would be an example of the angle, side, angle triangle congruence theorem. So again, the triangles would be congruent, but this time by angle, side, angle. Let's skip down to number 4 next. In number 4, we're told that AC bisects angle BAD. So here's angle BAD. If AC bisects the angle, we know an angle bisector divides an angle into two congruent angles. We're also told that angle B and D are congruent. So I'll use a different number of arcs in those angles to show they're congruent. Once we run out of given information, we turn to the picture. I notice that AC is a side in both triangles, and I have enough information here to say the triangles are congruent by angle, angle, side. Again, note the location of that side that's shared between the two triangles. It's not in between the pairs of congruent angles, so it's angle, angle, side rather than angle, side, angle. Let's take a look at our final way we're going to use to prove triangles are congruent. Now on the next page, you'll notice we're given two triangles, and when you look at the angles and the sides that are given to be congruent, it appears as though we have two pairs of sides that are congruent and a pair of angles that are congruent. But this isn't an example where we could use side angle side because the angles we're told are congruent aren't included between the congruent sides. So side-side angle would be a theorem you would think would allow us to prove triangles are congruent. However, it's not. One way to remember this is spelling side-side angle backwards. Okay? This is a good way to remember we never want to write that abbreviation on our paper to try to show triangles are congruent. However, in this example, we are able to show these triangles are congruent. Not because we have two pairs of sides and a pair of angles that are congruent, but because they're right triangles with two congruent pairs of sides, the hypotenuse and one pair of legs. Now, why would I be able to prove these triangles are congruent? Well, if they happen to be right triangles, one way to explain why the triangles would be congruent is that for every right triangle, we have the Pythagorean theorem, which can be used to find a missing side. So if I use the Pythagorean theorem with this first triangle, I would know that a squared plus b squared would equal c squared. And if I tried to use the Pythagorean theorem with the second triangle, where this side is also a and the hypotenuse is also c, then I would find that these two sides, the other pair of legs, have to be equal. So really, I could end up proving these triangles are congruent by side, side, side. Anytime we have two right triangles where the hypotenuse in each are congruent and one pair of legs are congruent in that same pair of triangles, we could end up using side, side, side. So this shows us that we're able to prove right triangles with the hypotenuse of each congruent and a pair of legs in each that are congruent is a valid way to show triangles are congruent. This is what we call hypotenuse leg. Let's take a look at a couple examples of triangles that we can prove are congruent using HL and review some of the earlier triangle congruence theorems we discussed. So in the first one, notice when we look at the sides and angles that we're given, it appears that we're given two pairs of sides that are congruent and a non-included angle. However, side-side angle isn't a valid way we can prove triangles are congruent unless we know the triangles are right triangles. In this example, we do know they're right triangles based on those congruent right angles. So this is an instance where I could use hypotenuse leg. So the triangles would be congruent by HL. Notice here's the hypotenuse of the one triangle, and it's congruent to this hypotenuse of the second, and I also have a pair of legs that are congruent. Let's take a look at number 2. Here we're told ED is congruent to AB. We're also told AC is congruent to DF. In the diagram, we're shown that angle A and angle D are congruent. So again, we have right triangles, but we're also given two pairs of sides are congruent and the angle between them. So this wouldn't be HL, but it would be an example where we could use side angle side based on the order of the sides and angles given to us to be congruent. In example number 3, again, we're given right angles where these two lines intersect. We're told HG and HI are congruent. Other than that, there's no other given information. So looking at the diagram, I do notice that both of these triangles share side JH. Since these are both right triangles, and I'm given the hypotenuse of each triangle are congruent, and another pair of legs are congruent, this would be another example of hypotenuse leg. In example 4, E is the midpoint of CD. That allows me to say that segment CE and segment DE are congruent. They're also telling me that angle A and B are right angles. So I have both right triangles, and angle A would be congruent to angle B. Once I'm out of given information, I turn to my picture. I don't have any instances where I could use the reflexive property, but I do have vertical angles. And this is enough information to prove the triangles are congruent. I have two pairs of angles, and I have a pair of sides that aren't between the pairs of angles. So this would be angle, angle, side. Again, I want to review with you the different abbreviations that are not able to prove that triangles are congruent. The first one, as I mentioned earlier, is side-side angle, or if you read this in reverse, angle, side, side. The reason that we can't use angle, side, side, or side-side angle to prove triangles are congruent is given a pair of congruent angles and a pair of two congruent sides, corresponding sides, notice how I can form two triangles with a congruent pair of angles and two pairs of congruent corresponding sides that aren't the same size and the same shape. Since I can form two triangles, even though two pairs of sides and a pair of angles are congruent, this shows that not all triangles would be congruent if they demonstrate the side-side angle relationship. Another theorem that could not be used in order to prove triangles are congruent is angle, angle, angle. The easiest way to show this is by thinking of isosceles right triangles. If I have an isosceles right triangle, notice how one of the angles is a right angle and the other two angles are both 45 degrees. So a smaller isosceles right triangle would also have angles of 45, 45, and 90. But even if these were to drawn to scale, you would notice that we can have isosceles right triangles that are different sizes. So not every isosceles right triangle will be the same size and the same shape. Therefore, the triangles are not congruent to one another. So angle, angle, angle is not a possible way to prove triangles are congruent. Let's look back at a few additional proofs. On the page before, we'll go back and determine whether we have enough information to prove triangles are congruent or not based on the given information. In the first example, we're given angle A is congruent to angle X, segment BA is congruent to segment YX, and segment ZX is congruent to segment CA. So, noticing the information we're given, we have a pair of congruent angles and two pairs of congruent sides. Looking at our diagrams, the pair of congruent angles is included between the two pairs of sides that are congruent. So this, we could say the triangles are congruent. Triangle ABC would be congruent to triangle. Make sure we get the order correct. So angle A matches up with angle X. AB is the side with one marking. So my next letter needs to be the other endpoint of the side with one marking, which is Y, and then the remaining angle Z. And the reason would be side, angle, side. In the second example, CA is congruent to ZX, BC is congruent to YZ, and angle A is congruent to angle X. Again, we're given two pairs of congruent sides and a pair of congruent angles. However, this isn't side, angle, side, because the pair of angles that are congruent is not found between the pair of congruent sides. So, based on the abbreviation angle, side, side, or side, side, angle, the only way these two triangles would be congruent is if this is a right triangle and I could use hypotenuse leg. In this case, it's not, so we do not have enough information to prove the triangles are congruent. On the next page, let's take a look at a few other examples. Now we have multiple different theorems to use to prove triangles are congruent. So you could use side, 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 angle, side, angle, side, angle, 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 side, or HL. But again, HL only works for right triangles. So let's take a look at a couple examples. We'll go ahead and write down our statements and reasons and create our T-chart. And in this case, I'm going to start by working backwards. We're asked to prove that angles ABD and CBD are congruent. So I'll label those in my picture with little question marks. And I notice that these are angles of the two triangles that are sort of neighboring one another here. So I'm going to try to show first that triangle ABD is congruent to triangle CBD. And again, I'm using rigid motions to help me match up corresponding angles. Now that I have a goal, I'm going to list out the given information next. BD is perpendicular to AC, and angle A is congruent to angle C. Given. The first piece of information, given perpendicular lines, allows me to draw right angles in my picture. So I can say angle BDA and angle BDC are right angles. And the reason is perpendicular lines intersect, forming right angles. In my next step, I can end up saying that these two angles are also congruent. And this will give me a pair of angles, or an A, toward one of these various triangle congruence theorems. The reason is all right angles are congruent. And I'll put a little A out in front of step 3, showing that I have a pair of angles congruent in the two triangles. The next piece of given information allows me to say that angle A and angle C are congruent. This is a free pair of angles that I don't have to do any work for. Just label them in your picture. Once I've run out of given information, I turn to my picture and I look for different theorems that I can use just based on the diagram without making any assumptions. And I notice that the two triangles share side BD. So I can say BD is congruent to itself by the reflexive property. That's a remaining pair of sides that are congruent, and exactly what I need to prove the triangles are congruent by angle, angle, side. So I'm going to write that the triangles are congruent, being careful to make sure that I matched up the corresponding sides correctly. And now it's easier, since I have different markings in my picture, to know that A and C match up, B matches up with B, and D with D. And that's by angle, angle, side. And then lastly, even though I'm running out of space here, in step 6, I now can finish the proof off by saying the angles I wanted to show are congruent are. And that's because corresponding parts of congruent triangles are congruent, or CP-CTC. Go ahead and try example number 2 below on your own. Click pause and then go ahead and play the video when you're ready to check your work. So I'll go ahead and write out my statements and reasons. And working backwards again on this one, we're asked to prove segments XO and YO are congruent to each other. So labeling those in my picture, I notice that I have a couple pairs of triangles with XO and YO as sides in them. So I'm going to use the other given information to try to help me figure out which triangles would be easiest to show are congruent. So I'll list out my given information here. And I'll label it in my picture. QO, being congruent to RO, is a pair of sides in the two triangles. And PQ and RS being parallel helps me because then I can find a pair of alternate interior angles that are congruent, such as angle Q and angle R. The reason is, if two parallel lines are cut by a transversal, alternate interior angles are congruent. Now, based on my picture, I have a pair of sides that are congruent and a pair of angles that are congruent. So I think it'll be easiest to show that these two triangles in yellow are congruent to each other because I already have an angle and a side in each. I'm out of given information, but looking at the picture, I notice I have vertical angles here and here. So I'm able to say those angles are congruent. That would be angle ROY and angle QOX, because vertical angles are congruent. That's the other pair of congruent angles that I need in order to show those two yellow triangles are congruent by angle, side, angle. So in step 4, we'll say the triangles are congruent, being sure to match up the corresponding angles and sides. And since segment XO and YO are corresponding sides in these two triangles, I can say that they're congruent last by CPCTC. We'll get more practice with some additional proofs tomorrow in class.